Hi, my name is Nina and welcome to Hive. Today we're going to discuss about glucose, the central fuel. Have you ever wondered where your energy comes from? You use it every single day, even without thinking about it. From blinking your eyes to running in PE, this thing powers it all. Still don't get it? Take a look at this then. You got it! It's glucose. The sweet little molecule is the secret behind your energy. But how does it work? And what are its characteristics? Well, let's find out. Take a look at this. What do you think gives us energy when we eat this? That's right, it's sugar or carbohydrates. Foods like this are broken down into smaller sugars, and one of the most important ones is glucose, a type of monosaccharide. Imagine not eating for a whole day. You'd feel weak, right? And you'd get energized when you eat. This tiny thing powers your brain, your muscles, and even your heart. It's like fuel. Glucose is one of a kind. Before we understand more complex sugars, let's first break down on what monosaccharides and why are glucose the star of the show. Take a look at this flowchart. Glucose is a critical fuel molecule that converts into usable energy. This process powers everything from muscle contraction to brain function, especially during physical activity or concentration. Glucose is preferred by the body as an energy source because it comes from carbohydrates, a macronutrient found in certain foods and fluids that you consume. Well, here's a question. Why do you think the body prefers glucose over other sources like fats or proteins for energy? Yes, glucose is readily available, quick to process, and produces ATP efficiently without needing oxygen right away, which is especially important when we need energy fast. Glucose is most biologically significant hexose. What is hexose? It's a type of sugar that contains 6 carbon atoms. Glucose is the most biologically significant hexose that most widely used by cells for energy production. It plays a central role in cellular respiration, entirely nearly every metabolic pathway. Glucose is like a car gasoline, a highly efficient, easily available fuel that makes it a body's default sugar for powering cells. Recall the foods that you eat every day, like rice, bread, or fruits. These are ultimately broken down by glucose. This formula is shared by other hexoses like fructose, but what makes glucose unique is how these atoms are arranged, which affects its behavior and function in the body. Think of C6H12O6 as a recipe with the same ingredients, but how you mix them makes a different dish. Did you know that in water, glucose doesn't stay in its straight chain for long? It naturally folds into a ring structure, which is much more stable in solution. On the left, we have the linear structure, also called as the Fischer projection. Here, glucose is drawn as an open chain of 6 carbon atoms with hydroxyl OH groups branching off. On the right, we see the cyclic form, called the Haworth projection. This ring forms when hydroxylic groups on carbon 5 reacts with the aldehyde group on carbon 1, creating a 6-membered ring called pyranose. Now, let's briefly discuss alpha and beta glucose. You see this carbon? The only difference lies in the position of the OH group. Below, the ring for alpha, above for the beta. Next, let's talk about isomerism. Glucose has a different form called isomers, molecules with same formula but arranged differently. One type is D and L isomerism. Based on the arrangement of atoms around the asymmetric carbon farthest from the carbonyl group, in our body, we mostly use D-glucose, which is biologically active form. Another interesting type is epimers. These are sugars that differ in configuration at just one specific carbon. For example, glucose and galactose are epimers at carbon 4, while glucose and mannose differ at carbon 2. Now that we've covered glucose structure, let's talk about how it does in our body. Let's start with the most important role of glucose: energy production. Inside our cells, especially in the mitochondria, often called as the powerhouse of the cell, glucose is broken down step by step to produce ATP, which is our body's main source of energy. Glucose is the body's main fuel source. Through a process called cellular respiration, glucose is broken down in cells to produce ATP or adenosine triphosphate. This ATP powers everything from muscle movement, brain activity, to cell repair and temperature regulation. Think of it like this. Just as gasoline powers a car, glucose powers the body. It keeps your muscles moving, brain thinking, and even your organs functioning. Now what happens when there's more glucose than we need? The body stores it as glycogen in animals and starch in plants. Both are just long chains of glucose. In humans, glycogen is mainly stored in the liver and muscles. When energy is low, like between meals or during a workout, the body breaks glycogen down into glucose. It's like your energy savings account. You store it when there's extra and withdraw it when you need it. And speaking of blood sugar, glucose also plays a critical role in blood sugar regulation. When you eat, your blood glucose levels arise. In response, your pancreas releases insulin, which helps your cells absorb and use glucose. When levels drop too low, the hormone glucagon signals the liver to release stored glucose back into the bloodstream. Let's now move on how the body regulates and uses glucose. Before we begin, where do you think we get glucose in our daily lives? Any guesses? That's correct. Glucose mainly comes from the food we eat. This is our direct source. Think of rice, bread, fruits, and sweet. These contain either simple sugars or complex carbs that our body breaks down into glucose. Now, for indirect source, the body actually stores glucose when we eat more than we need. Glucose is stored as glycogen in liver and muscles. And when we need energy, like between meals or during workouts, our body breaks it back down. Now that we know where glucose comes from, how does the body control its levels? The answer, hormones, specifically insulin and glucagon, made by the pancreas. After eating, insulin is released. It helps us absorb glucose for energy or storage as glycogen. Think of insulin as a key. It unlocks cell to let glucose in. When you haven't eaten in a while or during exercise, glucagon is released. It acts like a switch, signaling the liver. It releases glucose into blood, either from stored glycogen or by making glucose from other sources, in a process called gluconeogenesis. Insulin and glucagon work together like a balancing act to keep your blood sugar just right. Too high or too low can cause serious health issues. So, what's a healthy blood sugar level? Normally, it should be 70 to 99 mg per dl when fasting and less than 140 mg per dl 2 hours after eating. Anything above or below this range can be a warning sign, like diabetes or hypoglycemia. Let's have a quick check. If blood sugar is at 130 mg per dl after lunch, is that a high, normal, or low? That's correct. It's a normal one. Let's now take a look at the clinical significance of glucose, why it matters in real-life health situations. When glucose isn't properly regulated, it affects your body's energy supply, leading to disorders like diabetes, hyperglycemia, and hypoglycemia. Quick question. Do you know the difference between hyperglycemia and hypoglycemia? Hyperglycemia means high blood sugar. So basically over 140 mg per dl after meals or over 100 mg per dl after fasting. It's often caused by diabetes or poor diet, and symptoms can include blurred vision or frequent urination. On the other hand, hypoglycemia is low blood sugar, below 70 mg per dl. It can happen too much insulin or skipping meals, and can make someone feel shaky, dizzy, or confused. You might ask, what's diabetes? Basically, diabetes is a long-term condition where blood sugar stays too high because the body doesn't make enough insulin or doesn't use it properly. Uncontrolled diabetes can lead to serious issues like nerve damage, vision loss, or organ failure. Now, how do we test blood glucose? Here are 3 common tests that you should know. First is the fasting blood sugar, or the FBS. This test is done after at least 8 hours without eating. It checks your baseline glucose level. Next, second, the OGTT, or the oral glucose tolerance test. You drink a glucose solution and your blood sugar is measured at different times after. It's used to diagnose gestational diabetes or prediabetes. And third, HbA1c. This measures your average blood sugar over the past 2 to 3 months. It helps for monitoring long-term control in people with diabetes. Finally, why is glucose balance so important? Glucose fuels your brain, muscles, and cells. Insulin and glucagon help it in balance. Not too high, not too low. If that balance is off, you might feel tired, dizzy, or sick. And over time, it can lead to serious diseases. Think of it as a car's fuel gauge. Too much or too little, your body can't run properly. That's why healthy food choices, exercise, and regular monitoring are key to keeping your glucose levels steady. Phew! Oh my gosh, that was a lot of sugar to talk about, but a good guide. Let's take a quick look back. We learned that glucose is more than just a sugar. It's a monosaccharide, a hexose, and a central fuel that powers every cell in our body. We saw how glucose is broken down through cellular respiration to produce ATP, the energy that keeps your heart beating, your brain thinking, and your muscles moving. We also saw how it's stored as glycogen when there's extra, and how the body balances it with hormones like insulin and glucagon. And when things go off balance, that's when clinical problems can begin, from hyperglycemia to hypoglycemia and diabetes. But we also learned how to test glucose levels and how to stay on top of our health through FBS, OGTT, and HbA1c test. All of this tells us one thing. Glucose isn't just sugar. It's a lifeline. Your body's most trusted fuel. Just like a car runs best on the right amount of fuel, your body performs best when glucose is balanced. That's why choosing healthy meals, staying active, and knowing your numbers can make a difference. Thank you for joining today's session. Let's keep fueling right and learning even better. Until next time, Trailblazers, bye-bye!